All right, so welcome everyone. It's my pleasure to introduce Dr. Kelly Keikens, who will be joining us from Snap Incorporated to talk about optical engineering. She's a recent graduate of the program, worked with Dr. Barton, correct?
Yep.
And yeah, really excited to see the talk and take it away. Thank you.
Awesome. Wow, first invited talk. This is an exciting milestone in my life, I guess. But hi, thank you for inviting me. Thank you for letting me talk. It's nice to see some lab mates. It's nice to see some new faces. Yeah, as Greg just mentioned, I graduated just last May, so it's been less than a year. So I'm new into industry. So, come talk to me if you're nervous about that transition from going from school to the industry world, and like how crazy does that have, like what happens in that transition. I'm new to it, so I've got all the details there. So I now work as an optical test engineer for Snap Inc., which is the parent company to Snapchat, which is what most people actually know of. And I work in a small hardware group that's located in Boulder, Colorado, and we work on augmented reality glasses there. So I actually brought a demo piece. I think I have 4 of them with me, and hopefully they work this time better than the last time I came and visited. But feel free to, whoever's here in person, you can come and play around with those afterwards. But so we work on the hardware team in Boulder, Colorado on these augmented reality glasses. So, quick little survey here. Who here has heard of Snapchat? Okay, good. I'm in the right audience. There's plenty of places that we go and talk that has an older demographic that they haven't heard of Snapchat. And so it's always harder to start a talk with them because you're like, right, got to start at the very basics. All right, who here has used Snapchat? Okay, usually still doing pretty good. Who here has used it today? Yes. And last question, who's going to take a picture or a video and post it on the Snap app so that I can see myself later? Yeah, there we go. Yeah, so thanks for having me. Let's get started. When we talk about augmented reality, the first question that always comes up is like, oh, well, is that like virtual reality? Like kind of. So I want to take a minute to define kind of the reality spectrum as I see it. This definition kind of changes from person to person, company to company. So kind of match up on definitions here a little bit. So when I think of virtual reality, I think of you put on something that blocks out the entire current real world and it virtually creates a new world in front of you, not having anything to do with your present area. Whereas augmented reality is overlaying things on top of the real world that you can physically see. So then there's this mixed reality that's kind of anything in between. So I know there's some VR headsets that you can put them on and it'll take a video of the outside world and re-display it in front of your eyes, and then it'll overlay things. I would consider that personally a mixed reality view because you're seeing a digital copy of the world. So that would also be what I consider the Snapchat app is a mixed reality because you're getting a digitized version. So when I say augmented reality, and these are augmented reality glasses, you can see through the glasses and then we're overlaying things on top of the real world in front of you. So these are some of the examples of the lenses, so the software side of things that you would see in the Snapchat app currently. So, I mean, you're probably mostly fairly familiar with some of these. Some of these I did not really know about as much as maybe I should have until I started working at Snap and they're like, we released this cool lens. And I was like, what? So like most people are aware of the facial ones that like it'll adjust features and whatever. And this is a very good example of something that you can do in mixed reality, but you can't actually do it in pure augmented reality because you can only overlay things in the real world. You can't change the real world. Right? So I I can't look at your face and change your face in physical reality. I can just put something that covers it. That's really the only option that I have in augmented. So that's an interesting thing to think about when we're thinking about augmented reality. You have kind of location-based lenses. I think these are called landmarkers, where there's specified areas where, whether it be a collaboration with an artist and they'll put a virtual statue somewhere so that you can view it if you go to that location, those are cool ways to incorporate art into our world without actually having to go to a specific, without actually having to have the physical thing there. There's, let's see, what do we call these? Local lenses, basically based on kind of this landmarkers where you go to a location, and this also kind of incorporates some of the games that are available where you can do things at said location. Some of we're getting into some of the hand tracking. So there's some lenses based on if you move your hand, it'll do things. And within the augmented reality world, we're still doing some of that hand tracking where you can do things with your hands in front of the augmented reality glasses and move things within your view there. So that's been a really cool feature that's kind of up and coming. And then the scan feature, which also translates over to the augmented reality glasses, where scan the world around you and based on what it sees can come up with different suggestions. So this is an example of an art installation kind of based on that location-based lens. So this is in collaboration with Jeff Koons, and this was back in October of 2017. But there were multiple locations where his art installments were put, and you could go there with your Snapchat, with your phone and your Snapchat app, and open it up and see this art exhibit. But I think this little snippet of a video really highlights where we still have a problem there, right? We're still seeing the world and these cool things through the phone. And how many times do you walk into a room and everybody's just doing this, their own thing? Nobody's actually kind of interacting with each other anymore. So kind of our whole goal of making these augmented reality glasses are to get us to interact more naturally with each other, but still be able to have these cool experiences. Being able to just have this art installation in front of you and just see it and interact with it and interact with everybody else who's also seeing it, as opposed to putting up a blockade in front of your face. That's kind of the goal and why we're going this direction. Snapchat's about self-expression, and we want to make that a more natural thing that you can do and interact with others at the same time. So our product line is called Spectacles, and we are basically trying to figure out how can we do all of this at the same time? How do we make it interactive, not block off the world? And if you were to look at the absolute ideal requirements, what do we want this to do? We want it to be able to display as much as the entire human, as good as the human eye can see. We want it to be socially acceptable. We want it to be basically non-existent, but happen anyway. So, from the resolution of the eye to the field of view of the eye to the foveated resolution of the eye, to being able to wear it all day and not even notice that it's there, to not have it interact or impede your interactions with other humans. But we all know that's not physically possible. So a lot of our work in Boulder is figuring out what trade-offs can we make. There's always a field of view versus resolution trade-off, right? You increase the field of view, your resolution goes down. Same issues. So we're trying to get some of those studies done of okay, well, what are our limitations? If we have this field of view and this resolution, will people think it's good enough, or is it not worth it? And then there's also okay, well, We want it to be bright enough that you can take these outside and still see these augmented experiences. The Arizona sun is really bright. So that means now we have a power issue. And if we don't want it to be attached to some huge battery or have the full headset, whatever, okay, if our battery life is only so long, is that good enough or is that not good enough? So there's a lot of trade-offs, and just the trade-off studies is a lot of what we do in Boulder, as well as trying to research new technologies to try and push the boundaries of what is possible. Or yes, for those who and I'll just go ahead and if you just want to like play with them. I have a few sets with me, so if you want to play with them in person, for those that are in person right now, we can play with them a little bit later. But for those that are online, I have a couple of pictures, and it's, you know, never going to do it justice, but it's something. So this is kind of the base outline of the augmented reality glasses. And then this is kind of your exploded view to show some of the things that are in there. So there's dual waveguides. So it goes images from a projector on in the temples of the glasses, and then waveguides to get it to the front of your eyes, so that you can still see through it. And then on the camera or on the body of the glasses itself, it's also got 2 color cameras to capture the real world. So you can still take pictures or 10-second videos with this. It'll send it, and you can send it to your friends on Snapchat the same way you would with your phone. So it still has that base capability. So it's got the 2 cameras on the sides. It'll also then capture and overlay your augmented experience on what it captures. It has built-in microphones and a couple of speakers so that you would, you know, with your videos, you can still capture sound of wherever you are. And there's a touchpad on the right side for control with a couple of buttons on the top. So if you feel them, they're not terribly heavy in the way, like, I don't know if you guys have picked up some of the other augmented and virtual reality headsets that are like, boom. This is a little bit lighter than most of those. But it also, there is a battery in there, so it doesn't need to be tethered. There's no required connection to your phone in order to use these. So you can use these for a little bit kind of completely on their own. And then the one thing that we still have with these is right now the battery life on these is only about half an hour. So it's still very limited, and that's definitely one of the things that we're working on. As far as what it can do, where are we? What is our state of being right now, I guess? So like I said, we have these 2, and we have the 2 RGB cameras to capture the world, but this also gives us some of that depth sensing by having it offset from each other. So we're starting to get that depth information out of these. Those cameras have 120-degree field of view, so they're getting a very wide capture area. And because of that offset, you can do some cool computational things as far as like, if something is moving through your screen, you can kind of see how fast it's going based on the tracking between the 2 cameras. The display itself gets up to 2000 nits, which is bright enough to go out into the Arizona sun and like should be able to reasonably see it. And it'll do an automatic dimming so that when you walk inside and it's not as bright, it doesn't just flood your eyes with this really bright light. Right now, these are only at about a 26-degree diagonal field of view. Time will tell where that goes. And so fairly light, untethered, doesn't require a huge chunk of whatever, doesn't require external battery. Yeah. So bringing it into what it is that we actually do in Boulder. We really work on the entire spectrum from R&D all the way through the manufacturing process. So we're doing R&D research on new technologies that we could potentially want to put into future iterations. We're doing user studies as to, for these kind of trade-offs of, is this better or is this better when it comes to uniformity of the display or brightness of the display. Like we're doing user studies of what can the eye perceive, what's good enough, all of that. And we go all the way through developing tests for the manufacturing site. We do not do the manufacturing ourselves. The 20 or so people in Boulder would be a little overwhelmed trying to do that. But once they come out of the factory, we will get sets and do our own testing there to see if we design these test fixtures to give them the pass or fail test criteria, but then when we get it back in house, we'll do, okay, what is the actual absolute best resolution that we can get with these? What does the color performance of these look like? So we'll do more extensive testing after it's come out of manufacturing. So I did not push my buttons in the correct order. That's okay. But yeah, so research new technologies, assembly and test of prototype designs and features, test fixtures and test algorithms, and final tests of the product itself. Me personally, because I'm on the display test group, I work majorly in kind of the second half of this. So I work a lot on the designs of the test fixtures and the algorithms for the factory, as well as testing the products once they have been manufactured. But occasionally I do get to dabble in the R&D things. Some kind of an example of something that would be there is, let's say we wanted to change the material of the glasses themselves, but that's going to have an impact on how transparent they are. Will it affect the resolution of the real world that you see through it, right? Is it like this really foggy material or something, and now you can't see anything? So I'll do a lot of the testing on these kind of materials as far as what is the clarity and transparency. That would be an example of a test that I would run. Let's see. Okay. We have a lot of open positions. If anybody is graduating soon, yeah, come talk to me. I will be here through Industrial Affiliates with plenty to talk about all of that. And I think that is about my 20 minutes. So I think I timed this out all right. Yeah, ask me questions. Yes, probably mostly master's PhDs, but we are, our group has finally expanded enough that we don't require everybody to be a PhD anymore. We have enough expertise that now we are able to incorporate undergrads as well. So that's something that we are finally at a point where I think we're capable of doing that. Yeah. As in like the technology that's in there. I'm not allowed to say that much about it. I mean, there's LEDs, projectors, there's lenses and waveguides. That's pretty much the extent of what I can say about the actual technology itself. Yeah.
On the slide for human centric performance board, I think I mentioned that the ideal design for visual performance includes multi-focal. Is that sort of like for the accommodation in the eye, or what is that? Yeah, is that something that you design around at this point, or?
So that's one of those things of like, if we had completely ideal, we would be able to focus something here as well as put something out at focus at infinity, because your eye is capable of focusing at both locations. But right now you just kind of display something at whatever you say is focus. So right now it's all fixed focus kind of image display. But if we were to have our our best case scenario, we'd be able to change that. I don't know, and I'm not even sure of all of the things that we're working on. I'm not sure if that's one of the things that we're looking at now, or if that's a future possibility to look at.
So since you have the two cameras, can you use the different effectively getting different angles to different levels of perception?
Yes, yes. So there's definitely, you're able to, right, there's like calculations of like time of flight and things like that, that you can calculate velocity because of that. There's depth information that you can get from a scene because of that. I mean, right, like when you're looking at a stereo into a stereo microscope, like you're able to get much more information about a scene than just looking at a flat image. So yeah, we're definitely able to get some of that depth information.
I was just gonna build off of that, because I think like you can then apply the depth information as like a multifocal thing software wise, right? And you can tell like your whatever program that you have that put an object. Well, now the depth information, based on depth information I have, I'll change the location or focus location here or there.
So computationally in the software, you could definitely display each eye at different points in your field of view in order to get them to overlap at different depths. That for sure. The issue is changing the focus of the lenses that are projecting it so that it's not a fuzzy projection. But yeah, computationally for sure, you can adjust for that for the eyes and make it look like it would be at different depths. Yeah.
How is the adjustment from going to what sounds like doing medical research to going to doing something like display tech? What was that transition like? And how like, because I'm sort of also like worried that sometimes like, oh, if I want to do something else after I graduate, did you feel like you had a lot of catching up to do getting into display research, or did you feel like they're just stepping into that role?
I felt that the transition was much easier than I ever anticipated. I think especially this school is really good at teaching you a very broad range of things. And so it's the thing that you have this like very narrow focus of what you're doing in your research, and then you realize that, oh, these are the same concepts that are used everywhere. It's just applying it to a different use case. But all of the theory transfers from one application to another. So I found that to be much easier than I was thinking it would be. That was a nice surprise. Did you have another question? Yeah.
So actually, was there anything that you used to have done while you were doing it?
Ooh. I think in general, I wish that my programming was a little bit better. Right, like I did a lot of analysis in MATLAB while I was here, but I feel like industry uses more of Python. So I think I wish I would have dabbled in Python a little bit more before moving over into industry. Like, yes, I'm hardware and I'm optics, but that still is going to require some image analysis, which requires programming. So I think having a better basis in different types of programming rather than just like my MATLAB experience. I think I would have preferred that a little bit. Yeah. Good one. Yeah.
If I can see the projection made from this side, so can someone else just see from this side and know what I'm looking at?
Currently, yeah, currently that is definitely one of the problems. Like you can see the image from both sides of the glasses. That is one of the things, that's one of those, yeah, I think this falls under the social acceptability, not visible from an outside observer. Right now, if you have something displayed there, you have to be kind of standing at the right spot to see what they're actually looking at. But like, if I'm standing off to the side, you can see that there is something projected. You can see that there's light scatter happening. So ideally, we wouldn't want that, and it would be a completely your eyes only that's happening. But right now, because of the waveguide, there's the split of about 50-50 of the light going each way. So that's, yep, it's definitely one of the struggles.
I have a question for, you said you work on like analyzing the display systems after they've been manufactured. How do you go about defining useful figures of merit or to then convey to like say your customers or to your research team saying, okay, here's what we need to improve, and like are there any like standard figures of merit that display research uses to, say like we're doing this good?
There was an awesome XKCD comic that I found the other day. That is basically like there are 14 standards that currently exist. The middle panel is, oh, that's what there should just be one sometime later. There are 15 standards to describe. That is exactly what is going on. So we're working with the manufacturing plant, we're working with vendors, we're working with whatever. Our main thing is just trying to collaborate on what our definition is so that we can test it the same between locations. There's not really any good standards out there. There's just really not standards out there yet. So it'll be a little bit of a first to definition. Yeah, Jenna?
This is definitely not like part of your optical testing job or anything, but I wanted to ask if you know, I feel like part of the social accessibility in glasses, I think is definitely like aesthetically pleasing. And I thought like do something out with something like Ray-Bans and so, I mean, if like people are working on that, or if that's been like an issue with like trying to get people to use them, but they apply them because
Yeah, I mean, so we have our own product design team that, and they're the ones that kind of keep limitation, like as the optical engineering group, we're a whole bunch of people. We just want to throw technology in there and we don't really care. But then the PD team is like, whoa. We got to make this at least somewhat acceptable. They bring us back into the real world a little bit. Because like people do use the full headsets and whatever, but they're not going to wear them outside. Yeah. So this is a step in the right direction. I think this is, as far as augmented reality goes, I think this is the smallest form factor. That's untethered and whatever. As far as like the Ray-Bans glasses and all of that, right now, my understanding is that is just cameras, which if you look at Spectacle's previous designs that came out like 6 years ago, that's what it was. So Facebook is about 6 years behind. Not gonna, just gonna throw that out there a little bit. What Facebook has? Yeah, no, what Facebook has is just regular Ray-Ban sunglasses that they attach two cameras to. So, the Ray-Bans was just in order to make it a selling point and have a name known to it.
There's no more questions. I think our